Let me introduce myself. My name is Mike Schmidt. I work on the product team at Blockstream, and I'm also a contributor to Bitcoin Optech. And I'm here today to talk about return of fees. And so when I talk about return of Bitcoin fees, some of you may picture something like this, an oncoming train, something big and scary that you can't tell exactly where it is off in the distance. Something potentially that revives some bad memories, the Bitcoin fee spike of 2017, for example. We all saw people experiencing things like this, delayed transaction confirmations. This is a quote from Twitter. We've even likely experienced some of this ourselves, high transaction fees during that same period of time. So is there a way that we can make the fee market feel a little bit more like this? Can we reduce the impact that fees have on our business and our users from a usability and cost perspective? In other words, is there a way to thrive in a Bitcoin fee market? Thriving in a Bitcoin fee market means minimizing the impact that dynamic and sustained fees have on both businesses and users. So how are we going to get there? Well, we're going to start by talking about why are there fees and what have fees looked like historically. We want to talk about the challenges presented by fees for both users and businesses. We want to present a framework of solutions that we can put our different technologies and techniques in to address those challenges. So before we talk about a history of Bitcoin fees, it's important to talk about why we have Bitcoin fees in Bitcoin at all, what purpose they serve. The reason there's a transaction fee in Bitcoin is that you want to incentivize the miner to include your transaction in a block. Simple enough. Given that there's only so many transactions that can fit into a block, you start getting competitive with other transactions, and sometimes it's not as smooth as people gently waving their transaction fees in the nice blue sky. Sometimes it feels a little bit more like this. All the transactions are in there, but it's a little bit cozy, and perhaps towards the end of 2017, it even looked a little bit more like this. And I don't think that Bitcoiners transacting at the end of 2017 were quite as happy as these guys. Okay, so enough pictures. What does the data say about the history of Bitcoin fees? This chart is the next block fee rate over time. And what I want to draw attention to, and this is over the last 3 months, what I want to draw attention to is there's a star, a yellow star, and a pink box there. And that represents the start and end of a fee spike. The fee spike started at the end of March 31st, and over the next few days, the fee rate climbed 300%, up from 40 satoshis a byte to 160 satoshis per byte in just a few day span. So if we're talking about thriving in a fee market, one environment in which we're going to need to thrive is during fee spikes. So now let's zoom out to 3 years now. So this is the same chart from 3 years as opposed to the last few months. And so obviously we have those two spikes in 2017, but ignore that for now. I want to focus on something more subtle. There's two red X's, and if you can't tell, there's one that occurs in January of 2017, and there's a second X somewhere around January 2018. And why that's significant and a little bit more subtle is that transaction fees for a standard one input, two output transaction in US dollar terms crossed over $1 per transaction and didn't come back below $1 per transaction until over a year later. And most of that period of time, that type of transaction had a $2 transaction fee associated with it. So if we want to thrive in a Bitcoin fee market, we're going to need to be able to handle sustained fees as well. So thriving in the context of fee spikes and in the context of sustained fees. Well, what about the future? What might fees look like in the future? Well, no one has a crystal ball. It's possible for all we know that demand for Bitcoin transactions goes down, stays at the minimum demand at 1 Satoshi per byte fee rate, and it can stay there indefinitely. But I think most of us wanting increased Bitcoin adoption are pushing for more transactions on chain. And so if we are successful in that and we actually do onboard additional users and there's additional chain activity, we can see what that data might look like and how that might impact the fee rate. So this chart shows block weight in blue and the corresponding fee rate in red overlaid. And so this data is from 2017 through today. So you can see that there's this visual correlation that you can see when the blocks are full. You can see that a corresponding fee rate bump seems to occur when that block weight and that utilization of the block persists. If we zoom in on the last few months here on the right side of this graph, you can actually see a microcosm of that. And you can see that even at a micro level that the increases in the utilization of the blocks have a corresponding peak and trough with the fee rate as well. So also to note here is over the last few months, blocks have been filling up. Finally, this is a scatter plot showing similar data over 2017 through today. And what you're looking at is fee rate and versus the percentage that the block is full. And what's interesting here is each dot represents the average fee rate and the average block size for that day. So each of these represents a day. And you can see that as we're in the 40, 60, even 80 percentile of blocks being full, the fee rates are still quite low. But as we kind of get into that 90 and 95 percentile of block weights being utilized, you kind of see this spike where fees increase. And so you might say, great, well, we just said we wanted Bitcoin adoption. We want these blocks to be full. We want people to be transacting on chain. But there are some challenges presented with that. And there's two primary challenges for Bitcoin software and service providers when operating in these different types of fee challenges. So the first one is costs. So for businesses transacting on chain, an increase in transaction fees is an increased operating cost. And so sure, when transactions were a few pennies or 10 cents, the fee optimization techniques that we're outlining here may not have a large ROI. But the fact is that when fees increase and you're talking about $40 for a transaction, perhaps that 50, 60, 70% reduction in fee is more substantial at that time. And so like any business, Bitcoin businesses aren't happy that their operating costs go up. But the fact is that's the environment that we find ourselves in. And Bitcoin businesses that take advantage of some of the fee optimization techniques that we're outlining here and are prepared for the fee market to return are going to be at a competitive advantage against some of their competitors who don't adopt some of these techniques. Because whether it's the user paying the cost, those users are going to find a low-cost alternative. And if it's the business paying the cost of those additional transaction fees that are unnecessary to be paid, they're going to be spending unneeded capital. Additionally, there's user confusion that occurs during these fee events. And that can involve everything as simple as a stuck transaction that somebody doesn't know why that transaction hasn't confirmed, to users hesitating to even transact at all because they're worried about what the fee rate should or might be, or they're worried about doing something incorrectly, so they might not transact on Bitcoin at all. There's also the fear of overpayment and customers seeing that the services that they're using or the wallets that they're using are overpaying, and that can generate a lot of confusion and support tickets. And lastly, for some users there's a confusion, and for some services there's a confusion about who is even paying these fees. Is it a network fee? What is this? Is it a miner fee? I don't understand. Am I paying this? And so we want to make sure that we're clear on usability as well. So the thriving part of thriving in a Bitcoin fee market means minimizing the impact of increased cost and user confusion on our users. We want to minimize that impact as much as possible. Okay, so we sort of identified how this fee market can creep up in a couple different ways and a couple challenges that are presented in that fee market. So now we have a framework that we can think about solutions. So we have our sustained fees and our fee spikes. Those are the type of environments we may find ourselves in. And then we have the concerns of cost and usability. And so what we're going to do is we're going to try to put in some optimization techniques into each one of these boxes so that we're able to handle those different scenarios. And we have a hypothetical transaction fee meter over here, which we're starting off with a hypothetical unoptimized transaction. And we're going to try to see if we can bring that down into the green using a variety of the techniques that we're subjectively going to apply to this gauge. But first, I'd like to address a couple potential objections. So some of you may be thinking, why do I need to do this now? I just had a transaction confirm at 1 Satoshi per byte. Maybe this isn't a problem. Maybe this is just a temporary fee spike. And the fact is, these aren't huge engineering challenges, huge engineering undertakings that we're advising, but they can't happen overnight either. And so I really like this quote, "Seawalls are best built during low tide." And the funny thing is, as in preparing for this presentation, the slides were originally trying to motivate people that fees could come back, I swear. When in reality now, by the time I'm giving this presentation a few weeks later, fees have actually gone up dramatically. And so the actual fee market is speaking more than I could to in these slides. Doesn't Bitcoin Core want high fees? Well, the fact is the solutions that we're recommending today are in Bitcoin's current reality. We are not operating in a world where the block weight has been increased, that scaling via block weight increases have failed to achieve consensus. And we are not advocating as Bitcoin Optech for higher fees. We are just recognizing higher fees as a natural result of the environment we find ourselves in. So what are some of these existing technologies that you can put to use today, right now, and be prepared for higher fees? Dynamic fee estimation. So early in Bitcoin's history, Bitcoin wallets, including Bitcoin Core, used a fixed fee rate. And as we saw previously with the oscillations that occur in the fee rate, it's very difficult for something with a fixed fee to fit into that. And so over the last few years, almost every wallet has adopted some sort of dynamic fee estimation algorithm. However, some estimating techniques are maybe better than others. So sure, it's a competition to get your transaction in a block, but there's no points for being the highest fee rate in the block. In fact, that's just surplus to the miners. And so really winning is being the lowest fee rate transaction in a block. And so instead of targeting even the median, you can target the 80 percentile of transaction fees and try, whether that's in 1 block time frame, 3 block time frame, or 6 block time frame, targeting that 80 percentile can accrue substantial savings. The fact is, fee estimation is a huge topic that have its own presentation. And so the general recommendation here is to adopt a dynamic fee estimation algorithm and to keep abreast of research in the field so you can stay with the latest technology and perhaps even invest some of your own R&D. So in our hypothetical transaction, our fee estimation was improved slightly. We went from 100 to 95, but there wasn't a lot of gain there just yet. So we have to look elsewhere. So coin selection is the process by which your wallet chooses which of your coins or which of your UTXOs to spend. And so some general recommendations here is, where possible, avoid change, although there's some scenarios in which you could actually encourage change. We'll get to those a little bit later. But also spending the harder to spend outputs or lower value outputs during low fee rates so that you can clear those out. And then that enables you to have your easier to spend lower fee transactions for when the fee rates hit. Some consideration here, coin selection in general, would be privacy. So if you're combining unrelated outputs into the same transaction, there's always a privacy concern there. So assuming we got some small savings by avoiding change in some transactions, our fee rate meter went down slightly. We're now 90 out of 100, but we're still deep in the red, so let's see if we can find some big wins. Payment batching. Payment batching is similar to this man sitting in the train by himself. There is one guy in a car built for potentially many people. And so the analogy here is a single payment being in a single transaction. You could actually have multiple payments in a transaction. So there's this distinction between a payment and a transaction, and multiple payments can be in one transaction. This is a visual representation of that. On the left, you have these individual payments in transactions, and they each have their own overhead, their own train car, if you will. They're all riding solo. And in the batch payment example, you have a single transaction with 5 payments and just the one overhead. And so what kind of savings can we expect in this strategy? Well, in this chart, we're showing the bytes per payment and then the number of payments increasing. So as we add more payments to a batch, the fee essentially per payment is much less. And in the example that we showed previously with the red on the left and the green on the right, the red here is 226 bytes per payment, whereas the 72 is for 5 payments, 72 bytes per payment. And the difference there is 70%. So that's a huge savings, and we always advocate that if people aren't doing payment batching and they have a large volume of on-chain transactions, to adopt payment batching. Something to think about when you are doing payment batching is the usability. So by definition, you're putting multiple payments into one transaction. And by doing so, you may be waiting for that first, for additional payments to fill up that transaction. And that may cause delays in the recipient actually getting those payments. Okay, so now we're chugging along. We're down into the orange. We had some significant savings from payment batching. But where else can we find some big savings? Segregated witness. So SegWit is a huge topic. There's a lot of interesting technical things about SegWit. For purposes of this presentation, we're just mostly concerned about the discounts as it applies to the fee rates. So there is a discount in what you need to pay in fees when you are spending from a segregated witness output. And so the general recommendation here is to store your coins in SegWit addresses. And there's a couple ways, there's a couple sub-recommendations here that apply to that. So you'll want to default to receive inbound payments to a backward compatible P2SH wrapped SegWit address. That's a savings that doesn't impact your users from a usability perspective. You'll also want to send change. If you're sending coins out, you can send change to SegWit addresses so that you have those coins stored in a SegWit address for future savings when you spend those in the future. And then when you're internally shuffling coins, whether you're moving to multi-sig or doing some consolidation, you can also consolidate into SegWit addresses so that subsequently, when you spend those, you'll realize those savings. Finally, to benefit other users outside of your ecosystem, you'll want to adopt sending to Bech32 native SegWit addresses, which is just a slightly different looking address that has increased savings. And we'll show what those savings look like here. So these are 3 different types of transactions: a signal sig, 2 of 2, and a 2 of 3. And then how big is the legacy or the backward compatible P2SH wrapped or the native SegWit. And you can see visually that there's a good amount of savings here, moving off of the legacy format into a SegWit. And that is quantified by something like 25 to 45% savings going from a legacy output to a segregated witness output. And then going from that backward compatible P2SH wrapped down to a native SegWit output is actually fee savings of an additional 15%. A consideration here when implementing SegWit is just not all services have implemented SegWit completely yet, and so you'll need to make sure that whomever you're transacting with is compatible in the way that you need. Gemini actually just recently announced full SegWit support and did a case study write-up on Medium, which is quite exciting. Okay, so another big win puts us almost in the green, but let's see what else we can do to bring down costs. UTXO consolidation. So the analogy here is if I have a bunch of coins in my pocket, $20 worth of pennies, nickels, and dimes, that's going to be extremely heavy and bulky. And so I'm going to want to transfer those coins into something a little bit more lightweight, like a $20 bill. That's the same concept here with UTXO consolidation, which is take these low-value outputs and consolidate them into a larger output. Specifically during times of low fee rate, you'll want to do the consolidation. For 2 reasons. One, when you subsequently spend that larger output, the difference between when you consolidate it and when you spend that output is the savings that you've realized. So the lower you can be when you consolidate, the better. And secondly, at a lower fee rate, you can actually consolidate more UTXOs. Now, this is because certain UTXOs that have small values may be economically unspendable at certain fee rates. And so you'll want to spend those as low as possible. So if I have a 1 penny UTXO, it may be that it costs 10 cents to spend that. And so that is economically unspendable. So you'll need to make sure that you're consolidating when the denominations can fit that match. It also makes sense to consolidate two SegWit output addresses, as we've discussed previously. Zappo did a 4 million over a period of time in 2018 when the fee rates were particularly low. And they did a field report that's available on the Bitcoin Optech website, and I suggest you take a look at that if you're interested. Some considerations when you're doing consolidation would be it's speculative, so you're sort of assuming that the fee rate is going to change in the future. And so it could be you're assuming it's going to go up, and it actually goes down, and you consolidate it at a higher point than you needed to. So you need to be aware of that. OK, so our hypothetical transaction had some savings. It's hard to say exactly what a consolidation would save you, because it's really the difference between the time that you consolidated versus the time that you end up spending those outputs. But for now, we're completely subjectively in the green. But is there anything else we can do? Patient spending. The idea behind patient spending is that not every transaction has a super urgent next block priority, and that by waiting additional blocks to get your transaction confirmed and setting an according fee rate can result in high savings. So which block should you be in? That's not something that we can say. That's based on your business use case and your priorities. But as fees oscillate over time, this option is available to potentially defer next block spending into a maybe 6-block setting confirmation. So what savings can we expect with simply targeting 6 blocks instead of next block fees? This chart shows what from year-to-date 2019, what sort of 6-block savings you have versus next block. So if I'm targeting a 6-block confirmation versus a 1-block confirmation, what am I saving? And the savings here, as you can see, are upwards of 60% several times. And so there's some huge savings to be had here. Something else to note is actually during the fee spike that we talked about earlier in the presentation, those savings for 6-block versus 1-block confirmation times actually went to 0 because the demand for the block space was such that it actually cost the same to confirm in 6 versus 1. That fee rate was the same. Some considerations when using patient spending. Well, your recipient might not be quite as patient as you are. So you want to make sure that your receivers of these types of transactions are aware that potentially there's a delay. One way you can consider doing that from a user interface perspective would be potentially having a checkbox similar to traditional e-commerce with expedited shipping. You can have this notion of expedited transactions that confirm in a shorter window. Same considerations we had previously in terms of speculation as well. You're sort of speculating that the fee rate will have a window opening of lower fee rate in the future, and that may not happen, and you may have to actually rescue that transaction, which we'll get to in a minute. OK, so we brought down our transaction costs into the green, but what about usability? Replace by fee. Replace by fee is the ability to take a transaction and bump its fee rate, essentially. And we'll take a look at visually how that works here. We have our user who's broadcast an initial purple transaction at 0.01 BTC fee. It may be that there's been several blocks that go by and that transaction hasn't been picked up because the fee rate is too low. After some period of time, that user then broadcasts a replacement transaction, this green transaction here. And because it has sufficient fee, because of the increase, that green transaction then confirms, and we discard that purple transaction. So that's conceptually how replace by fee works. And so it is a mechanism to rescue a transaction that may not be confirming if you're doing patient spending or some lower fee rate speculation that doesn't confirm, and RBF can bump that fee up so that it gets confirmed. Some considerations when using replace by fee. The usability is different between different services. Namely, this transaction ID changes from the original transaction to subsequent replacement transactions. And that can cause some confusion with different block explorers handling things differently, users looking for the old transaction when the new transaction is there. We actually did a study of how the ecosystem supports replace by fee, and we published that on the Bitcoin Optech website. So please take a look at that. And we're actually in the works with creating a website that can showcase that data at a more underlying level. And so look forward to that coming soon. Child pays for parent achieves a similar outcome to RBF in that it's an effective increase of fee rate for the transaction, but the mechanism is a little different. And in fact, it's a little bit better because you keep that transaction ID, and so there's less confusion that results there. So let's take a look at what that looks like. On the left, we have a single transaction with a fee rate of 10 Satoshis per byte. That transaction, for whatever reason, is not confirming. We need to bump it, that fee rate up. Perhaps the fee market has something more like 12 Satoshis in mind for that particular transaction. So on the right, we have this transaction package, which we actually take a part of the first transaction, an output from the first transaction, and spend that at a significantly higher fee rate. In this example, 14 Satoshis per byte. And that brings the whole package itself up to a higher Satoshi per byte fee rate, which is 12. And that is a way that you can then get that entire package to confirm. Because when miners are mining blocks or mining transactions, they want to see the package fee rate and not necessarily only individual transaction fee rates. Coinbase actually published a case study on their child pays for parent usage. And the way that they do this is if in a withdrawal scenario, when someone's taking funds off of Coinbase, if a transaction doesn't confirm within 4 blocks, they execute this sort of technique, this child pays for parent transaction, to raise the fee of that transaction so the user gets that withdrawal. And more interestingly, they actually do that in batch. So they're combining batching with child pays for parent. They have a case study on their blog that I recommend you take a look at. These two screenshots are from a wallet, mobile wallet Conio, and I thought this was a great way to showcase, to wrap up some of these technologies in a nice usability shell. And so on the left, you see this receive faster button, and what that is that's essentially wrapping child pays for parent in a nice, concise receive faster button. Likewise, on the right screenshot, there's a send faster button, and that's wrapping up replace by fee. So you can see how maybe this sort of a way of wrapping up these more complicated technologies for higher usability can be done. So what are some technologies that are coming that affect fee rates and how much you pay in fees? Well, the obvious one is Lightning. Lightning is technically in beta, although it's being used in production systems, several production systems now. Many payments can be made near instantly with very low fees, and so that's great from a fee rate perspective. And we'll have Sergey's presentation covering Lightning with a little bit more detail in that. We put Lightning in this usability sustained fees box. Sure, Lightning has cheap transactions, so it could be seen as a cost savings, but they're also instant, so it's also a highly usable technology with respect to sustained fees. What are some other technologies that we have coming? We have Schnorr signatures, which result in smaller signatures. We have threshold signatures and musig, which result in smaller multi-sig transactions. We have Taproot, which in many cases you can have a complicated smart contract that doesn't even need to be announced on chain. Lastly, a note on education. So we presented a lot of technological solutions to fees here, but thriving in a fee market isn't just a technology-based solution. We need to educate our users on how to use some of these technologies that we're rolling out. We need to do it in a way that is usable for them and that they understand what's happening also with the Bitcoin fee rate and why all this is happening. So even something as simple as some help text or a little question mark explaining what the miner fee is something that I think is subtle, but a bunch of this education now is going to save a little bit of headache later when fees increase. So to revisit our final matrix, we put each one of these techniques in their own box, but really, as we talked about with Lightning and a lot of these, they could apply to different scenarios. And not only that, but you can combine them together and actually use them together in the example of some of the payment batching and child pays for parent. So in summary, what Optech recommends is don't overpay transaction fees. Use the existing technologies to make sure you're paying the minimum transaction fee. Use existing technologies to improve the usability. We talked about RBF, we talked about child pays for parent. set user expectations by educating them. Adopt layer 2 technologies like Lightning. And lastly, utilize Optech's resources. We have workshops that cover each of these topics in depth. We have newsletters. We publish research and studies. And if there's something that you'd be curious about seeing and don't want to see, please reach out. So my hope is that you feel a little bit better about being empowered to thrive in a Bitcoin fee market.